Hello, everyone, and let's analyze mission number 2 in depth. So at least 2 songs of type C. Remember, this is the distribution that we have. So the first approaches would be the following. The first thing is to notice that for n equals 1, it's just impossible, 0% chance to fulfill this mission or to have success. Because, I mean, you need 2 songs. So if you draw just one from the playlist, it's just impossible. What happens if you have n equals 2? So your intuition would say it looks really hard. And you could press your students to do some quick probability. No computations or hard calculations, but just noticing things. You could say, if you want to draw C, a song from C, as the first song when you're drawing 2, you have only 4 out of 25 chance. And then you still need to draw the second one to be a C. So you would have 3 because you already depleted one of these out of 24 because you already have one, right? So it's now 3, 1 less here, out of 1 less here. So 3 out of 24, that's 1/8 or like 12.5% chance of drawing the second C. So it's like passing these 2 tests, first 16% chance, and then, okay, you're good, but then you have to draw these. So it's really bad. So n equals 2 looks really hard to get. What else could we say? If we want certainty, you need 23, or more, because worst case scenario, we keep drawing here, just nothing of type C, just type A. Then we draw these, for example, 19, 20, 21. And then after 21, we're all in good territory here, so we just have to draw 2 more, so 22, 23. So, I mean, it's very close to the total, so it's really bad to get total certainty. We need 23, 24, or 25. So it's certainty, 100% chance, but it's clearly not the best strategy in the game because you could probably do with slightly less n's, very close to 100%. That should be the intuition. Because this was just a worst, very, very bad case scenario, like the worst we could do. So the question is, what do we do with more n's? And then it's in part 2, where the kids will get this graph containing these probabilities. Essentially, for example, for 14 would be close to 80%. Let's take a look here, 14. They could take a look and just approximate. That's 80% chance of passing the mission. They could see that with 1, there's no bar, and with 2, it's just 2%, very, very bad. And up to 23 and more, it's 100%. But look, here it's almost 100% anyways for these 2. So the interesting thing is, what do you do? Which n gets you good in the game? So n equals 1, sure failure, more than 23, or equal to, more than 22. Sorry, so 23 or more, sure success. For example, 11 is likely to succeed, but it's kind of risky, 60%. And n equals 20, it's much less risky. So for example, if you play 2-player game 20 versus 23, 20, almost all times, both will pass the mission, and always 20 beats 23 because it's just less. So it just looks like a much better strategy. In other words, if you know that player 1 picked 23, you might as well just pick 22 or 21, whichever. Let's make some comparisons now. So this could go with some of your students if you have the time or if you want to challenge them. And it's also good for you to prepare for the meeting to gain more conceptual understanding. Let's analyze 10 versus 23. Let's just say we're playing 2 players, which is a better strategy. We picked 10 because we just want to explore what happens when you're close to 50%, just slightly above, if this is good or bad strategy. And let's just play against 23, which we saw it's clearly not the best strategy in the world, but at least it gets you 1 point each round you play. So if we play 100 games, then for n equals 3, you would expect about 53 of those games to get 2 points because you're going to pass the mission and beat the other player. So that's twice this. So 106 points. Not bad, but kind of in the middle. And n equals 23. In all these 53 games, they still pass the mission, but they don't get the 2 points because they're beaten by 10, of course. So that's 53 points. And in the rest of the games, they'll get 2 points. So we multiply 47 times 2. So 94 points. And then we add. So n equals 23 beats n equals 10. But what happens if we then, yeah, so we say n equals 10. It's not going to win against many of these guys here, probably, right? It's going to lose against these guys that are on the top here. But what happens is you just raise it a little bit. So just 2 more in our playlist. So it doesn't look much. Of course, you're jumping from 50% or so to now 67.22 or so. So let's just approximate to 2/3. So if we win 2/3 of the time, let's see what happens. It's the same ideas. Let's keep it now with expressions to see regularities in our reasoning. So n equals 12 for 100 games. In about 2/3 of the games, you get 2 points. So that's 2 times 2/3 times the number of games. So essentially 4/3 times 100. It's an approximation. Of course, the number of points, it's an integer, but we're just approximating here. It's just an expected value. And what happens to the other player? The other player always gets 1 point in each game. So in those 2/3 of the games, they'll get 1 point. So this is this expression here. And in the other 1/3 of the games, so he gets kind of a smaller cake, smaller piece of the cake for getting 2 points, right? Whereas n equals 12 gets a bigger piece of the cake to get 2 points, but gets 0 points in the other third of the cake. Whereas this is kind of, it's a compensation. So it's more balanced. Because in the other 1/3 gets 2 points, so gets this. What happens magically is if you add this and this, they all have 100, and here is 2/3 plus 2/3, really. So 4/3 times 100 points. So we have a statistical tie. So, so it's expected to tie. So here n equals 23 is expected to statistically tie. We expect a tie between 12 and 23. What happens is that if you put something even that's more than 12, but even less than 23, like 22, 21, 20 or so, such that this probability is not 100%, then this analysis is exactly the same. So they still get these points for n equals 12, but the other n, 22 or 21 or whatever, even 13, whichever number you put that it's between 13 and 25, this can only drop here, this expected value. So it's not going to be each time, but whatever many times of the probability. And same here, it's not each time. So the conclusion is that maximum this number of points, that's the upper limit, upper bound. So they'll get at most this number of points. So what's really cool here is that this is the discovery that if you look for n in whichever game, doesn't have to be the mission 2, it can be any other mission. If you look for the n that corresponds to 2/3 of the probability, this n will statistically never lose against a larger n if they play just 2-player game. So what's going to happen is that any n here, let's call it x, that's from 13 to 25, where the probability is just some p, doesn't matter which, they're going to get the total expected up to. So the conclusion is that n equals 12 is expected to not lose. Statistically, right? It's a statistically sometimes tie, and sometimes just beat the other player. which brings us to this nice discovery. So 66.6% in this game is kind of a sweet spot. It's a good strategy, at least in two players game, if you know that, or if you predict, right? Becomes like game theory. If you predict that your opponent is gonna go for higher values of n, right? Like 70%. If you know that it's like a conservative opponent, like goes for 90% or 70%, 75%, if it's not a risky player. What would happen if it's risky? Well, that's another consideration. So you activate curiosity in your students and you try to go deeper because, I mean, these are easy. These are okay, especially for students that did meeting one when they know this, this certainty condition. So you're going to go deeper and you still can do computations. These linear combinations are nice computations that they can play. And how do you guide students? Well, you try to guide them to look for 50% around that neighborhood to see what happens. And also, that's a much bigger guidance, look for 66% or so. They could still try 80% or 100% or even low to see what happens and play these mini competitions or these mini games. So I hope this helps and see you in the next video. Goodbye.